Hi friends, welcome to my channel. Today we will see another problem. And we will solve it using Matlab. While solving this problem, we will learn about some other basics of the Matlab. We basically in today's video we will focus in on logic. How logic helps us to evaluate some kind of problems in Matlab. So what is the question? Question is based upon the following equation. What percentage of y values are greater than 0.8 for x equal to 0 to 10? The equation is y equal to sin x. Uh, you can see my previous videos where I have used some Linspace um, equation in the previous video for solving an equation and for giving the example of plotting. I have taken a Linspace function and given some values, some data points. For those data points I have generated this y value, and then we plotted those and all things. But now we need to know how many values of this y are above this 0.8. See, this sin x, we can put x, we can put 10, we will get some kind of y. But how many values if you generate that will give you a percentage? That we need to know. So y value we know, we don't know about period. What is the period we don't know. Uh, so y value, we know that y value, sin value will be between -1 to +1. So definitely some of the few of the values are more than 0.8. So I will open my Matlab and will try to solve this while learning some other things. So let me open another script. So let me try x equal to Linspace. X value is between 0 to 10. So what Linspace will do, we all know. I told it in previous videos also. Linspace will generate 100 equispaced values between these two values. If we give the third argument, it will generate that many values between the lower limit and upper limit. And y is sin of x, so it generates sin value. Let me, okay, first you need to, first we need to save to run. So what happened, I have generated some values for x, some values for y, 100 values almost. See, there are variables, previous variables also. Why this came? Because I haven't given those three statements what I told. What are they? CLC to clear the command window, clear vars to clear the variable, and close all to close the figures. Close the figures. Let me run now. Control enter is the shortcut. So now control S, control enter. What happened? So we got clear variables. Now let me plot this. What is this? Plot x comma y. So what it will give? It will give, see, it gave a sine wave. X varies from 0 to 10. What is the sine value? Sine value is between, so let me try to split. We will see here. So sign value is between -1 and +1. Now uh, let's write some dot. We'll see what will happen. So now these are the data points. We took 100 data points between 0 to 10 for x. So these are the data points. So now I want to plot some more on this. For that, what we should use, hold on will keeps the plot like this, and then this plot we can give arrays. We can give arrays for x and y. So for x I'm giving 0 space 10. So x will be varying from 0 to 10, comma. In place of y I'm giving 0.8, and I want other value to be 0.8 only. Then I want a line which is color, let's say red. Now I'm running this. See, so this is the 0.8. That means the values which are above this red line are the values we require. So below this red line are, so these are total number of data points. The data points which are above this red line are the percentage of values which are greater than 0.8. So before solving this problem, let's learn some basics of logic. So what logic will say? Suppose x equal to 5. I am assigning x equal to 5. So logic will say x, I'm giving x greater than 2. That means it checks whether x is greater than 2. If it is true, it gives a logical 1. If it is false, it gives a logical 0. So we can check multiple values also. Like suppose for a matrix, I will create a matrix with all 1 cross 10 matrix with all ones. So 10 matrix. Now if I want to check a greater than 0, yeah, everything is 1. Now suppose capital A equal to ones of 1 comma 10. So it generates 1 by 10 matrix with all ones, and multiply. Matlab follows matrix algebra, so it will generate A with all 5s. So then if I suppose check if A is greater than 0, it checks each and every element of this matrix and then gives the answer. So all the elements are greater than 0, so all are ones. That means true, 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 true. Now what is sum? Sum is an inbuilt function. It adds all elements of your matrix or array. So sum of A is 50. 10 5s 50s. Now we can assign this logic to a variable also. Let me say result. Result is a variable I have taken. Result equal to A greater than 0. That means if A is greater than 0, whatever value is greater than 0, the logical array is assigned to result. Now if I want to know how many values are greater than 0, then I can sum these values. So now the answer is 10. So 10 values of this array are greater than 0. And some other logics like 8 greater than equal to 8 s, it's logical 1. And 9, some other values like 19 plus 5 is less than 100, it's logical 1. And 55 is this symbol, the left top one, call it as tilde, is used for not equal to, not equal to 20, then answer is logic 1. And compound checks also we can do, like and or. See, suppose 10 greater than 5 and logical and 11 greater than minus 100. If both these expressions are true, then only the output is true. Suppose this is less than, okay, sorry, it's not a script, it's a command window, so you cannot copy that, but you can go by pressing upper arrow. See, logical 0, 1 is true and 1 is false, but also logical 0. And you have logical compound expression for r also. So r is this, and 11 less than, if one of these two expressions are right, then also it is logical 1. Okay, so one of these expressions are less than 1, then it is also. So now let's go back to our problem. So what is 1 greater than 0.8, yeah, we'll agree, yes. So now we want to know how many values are greater than 0.8. So what should I do? Shall I continue in the command window or script? Let's go back to script, so that the execution, every line will not be executed now. So let me say y greater is a variable I am creating, y greater equal to y greater than 0.8. So let's see this also here. Let's see this. See, lot of variables, everything created here. Once I run, because of these equations, all these will be closed. Maybe this figure will be closed and reopen again. So now let's run this. What will happen again? This is, see, variables are cleared. Now this y greater array, this is, I think. So now we can check how many variables are there by using this whos, whos. So these three are there. This is logical array, these two are double. And now let's see sum of this y greater can do. So what it gave, it gave 25. You have 25 values now. Now if I want to take more values, let me take 10,000, 1 lakh values. Take 1 lakh values, what will happen? Control enter. See, it's creating so many values, 1 lakh values, and these many are above this red line. These many are above this red line. So uh, final percentage is equal to sum of y greater than how many above 0.8 divided by total points are 1 lakh 1 2 3 4 5. So now two arrays are getting created, and now this is the percentage. If you multiply with 100, it's 25% almost. So we are a programmer, we don't want to write 10,000 here. What can we do? We can write, we can do one more thing. I don't want to execute all these. I want to suppress the output of these lines. I want to suppress the output of these lines. Yep. Let's see, actually suppressed. So I am taking it as length of y. There are three height of a matrix or array. Height tells about it gives number of rows. Okay, height of y, it gives number of rows, and width gives number of columns. And length gives the higher dimension of both columns and higher dimension between uh, column and row. Whatever the higher dimension, it will gives that dimension. See, here width is higher dimension, so it gives the width. So this is length. So if you want in percentage, you can multiply this by 100. So it follows the algebraic rules, but as a programmer I want to be clear, so I have taken some braces, extra braces. So now me running this. So now 25% it is 25%. Okay, plot also came 25%. Okay, now so this y greater is still generating. I haven't suppressed the output of y greater. So generally this is for 0.8. Let us take some variable. This is also a variable or a parameter. Why I should keep 0.8? Let me keep it as y check. So then I will keep here in the plot also I am changing y check and here y check. Okay, we'll keep this y check somewhere here. Y check. This time I want to put it as 0.5. Y check. Now let me run this. Somewhere is problem. Okay, it's not colon, it's semicolon. Now 41% is above 0.5. 41% of values are above 0.5. See, generally what we do as a programmer, we will forget like we don't want to disturb the code. We just want to change some parameters in the code, and the same code will run for different parameters. So as a programmer, what we should follow is, first we develop parameters, and then we will write actions. What are the actions to be done in the program? And then we write what the outputs the program should give. Now we can see one thing. See, uh, we'll try to do one thing. I am trying to put my grid on. Yeah, this is the grid, so that now it's good to see. Let's see, what is this value? X value is 6.279, 6.28 something. So if I want a single cycle of this sine wave, what my x value should be 6.27. So suppose if I want to write this as 6.27, what I'm getting? Oh, I should not change this. I'll need to change this here also. Okay, 6.27. Now this much one cycle I got. So for this I can take another parameter like max x equal to 6 point, let me round it off, 6.3. so here this max x I should use here, control V, and here control V. So for one period I need to get somewhere it's wrong. Yeah, semicolon, control enter. Somewhere it's wrong again. Line 4, what's this line for? Okay, yeah, see, this Matlab will sequentially do. So max x I should define before this line. I have defined after this line previously. So now I define before this line. So, and this is also showing we can use Xlim. I introduced this function in the previous. So Xlim can be 0 to 6.3. Okay. Something wrong again. Let's go to documentation for Xlim. I forgot. What is this Xlim? Yeah. Xlim limits. Okay. Oh, in this way. Another bracket. Okay. Yeah, we got. See, final percentage is 33%. Now let me change this by check to 0. Now control enter. See, exact 50%, just above, because Yeah, 6.3 we did. If it is 6.28, then see, that's it. 6.27, that's it exactly. I hope you understand this problem and the basics of logic, how to use logic to solve the problems. I'm ending this video now here. So thanks for watching this video. Share with the people who need Matlab, who want to learn Matlab. This series I developed by keeping beginners in the mind. So please subscribe to my channel and press the bell icon so that you will get notification whenever I upload a video. Like the video so that it will reach for more the people and encourage me. Thank you.